Hello dear students, welcome to the course of Engineering Thermodynamics. Myself Mihir Mistry from Mechanical Department of LJ Institute of Engineering and Technology. So today we are going to discuss about introduction and basic concept of engineering thermodynamics. Now the points that we are going to follow today is the very first is microscopic and macroscopic point of view. That will be followed by thermodynamic system and control volume. That will be followed by concept of continuum, and at last we will discuss certain definitions like properties, state, change of state, then path, process as well as cycle. Now let us discuss about first point, that is microscopic and macroscopic point of view. So microscopic point of view is also known as statistical approach. Why it is known as statistical approach? Let us understand. Before that, microscopic approach means what? So microscopic means the events occurring at molecular level are taken into account. That will be known as microscopic approach, meaning you will be bothered about individual behavior of molecule, right? So you will track down individual molecule. So that will be known as microscopic approach. Now why it is called as statistical approach? Let us understand that. So as you can see on the screen, I have taken certain molecules in the vessel. Now let us assume that there are 10 raised to power 20 molecules present in over here. Now if I want to define the coordinates or position of any one molecule, then what I will have to do is I will require three coordinates, that is x, y and z. Now if I want to define velocity of that particular molecule, then I will require three velocity components respectively in x, y and z direction. So together, if I want to define velocity of all molecules present in this vessel, then what I will have to do is I will require 6 into 10 raised to power 20 equations. And if it is difficult to solve this many equations together and simultaneously, so what one can do is one can do the statistical mean of these equations, right? So that is why this approach is also known as statistical approach. Now the very next approach is macroscopic approach. It is also known as classical approach. Why it is known as macroscopic approach? So simple, events occurring at molecular level are taken into account. That means what? That means simple, you will take average behavior of all molecules, right? So let us understand it by simple example. For example, a room temperature is defined to be 25 degrees Celsius. So that means what? You are very well aware that practically each and every molecule of that room will not have the same temperature, that is 25 degrees Celsius. Certain molecules will have 25.9 degrees Celsius, 24.9 degrees Celsius, 23 degrees Celsius, 26 degrees Celsius. But in average, they all are said to be having temperature of 25 degrees Celsius. So temperature can be defined as macroscopic property or macroscopic approach, right? Same way you can define the pressure also. So this is how the microscopic and macroscopic approach is taken. This subject is dealing with in context of macroscopic approach only. Now next is thermodynamic system. So as you can see over here, a system is shown by a simple oval shape. Now thermodynamic system means what? It is the region in space upon which attention of focus is made. That means what? Simple, it is the area or volume upon which your attention is focused for the analysis of the problem. That will be known as system. For example, you want to install an air conditioner in your bedroom. So your bedroom volume or bedroom area, that will be your system. Okay. So that is how the system can be defined. So, and everything except the system will be known as the surrounding, right? And system and surrounding, the parting line between the system and surrounding, that will be known as boundary. Now system and surrounding together will be known as universe. And remember one thing, surrounding is also known as environment, right? System and surrounding together will be known as universe, right? Now there are certain classification of system, that is known as types of system. So thermodynamic system can be defined in different types. The very first is open system. Open system is also known as control volume system. So let us understand what is the meaning of open system or control volume system. So open system means simple, the mass as well as energy can transfer from the system to the surrounding or from the surrounding to the system. vice versa will be the case, right? So that is what is called as open system, right? So for your understanding, I have shown certain mechanical equipments that are known as open system, right? The very first is boiler, the second is heat exchanger or condenser, and the third is compressor. So these all are open system. Why they are open system? Because as you can see, the fluid will enter from the device and the fluid will leave from the device. So mass is entering and mass is leaving. That is why it is open system, as well as the energy will also enter the system and energy will also leave the system, right? So in terms of heat, so that is why it is known as open system, right? Now the next classification is isolated system. So isolated system means what? Very simple. Neither mass nor energy can transfer from the system to the surrounding. That will be known as isolated system. Now let us understand what is the meaning of isolated system. Okay, simple. Let us take example of our universe. So nothing can go beyond the universe, neither mass nor energy, or nothing can enter in the universe. So that will be known as isolated system. In some textbook, thermos flask is also taken as isolated system, but you can consider it for a little time being, right? Because it is a closed system if you take it on an exaggerated view, right? So isolated system, the best example is what? Universe, right? Now the last system, that is closed system, it is also known as controlled mass system. So why it is closed system? Simple. Why is this controlled mass system? Simple. The mass cannot transfer from the system to the surrounding or from the surrounding to the system, but the energy can transfer from the system to the surrounding or vice versa, right? So that is why it is known as closed system, right? Now closed system examples are shown over here on the diagram of the screen. The very first diagram is showing the vessel, that is closed vessel, and if the vessel is closed, the lid is closed, then the fluid cannot transfer from the vessel to the outside or from outside to the vessel. The another example is what? IC engine. So in IC engine, as you can see, particularly the second and third stroke, that is what? Compression as well as expansion stroke. During these strokes, what will happen? The mass cannot enter into the cylinder cavity or the mass cannot leave from the cylinder cavity. So during these two strokes, the mass is constant, but energy can transfer from the system to the surrounding. So that is why that will be known as example of closed system. Okay, I hope it is clear to you guys. Now concept of continuum. So very simple to understand. Concept of continuum means what? So if you take any volume or any gas, liquid or solid, so we are very well aware that molecule size is very less. So compared to molecular size, the vessel size is very large, right? So what you can take is, if you take one glass of water, then in that one glass of water you will be having billions of H2O molecules present, right? So you can take that, or you can consider that H2O molecules are arranged in closed packed manner like this, right? So if you take that thing in consideration, that will be known as continuum concept. Okay, continuum concept means what? Your matter is distributed continuously and evenly throughout the substance. That is known as continuum concept. Now it violates its validity when the mean free path reaches the magnitude of the level of the volume of the vessel. Now let us understand this typical statement. Now before understanding that, we will have to understand what is the meaning of mean free path. So let us understand mean free path. Very simple. As you can see on the screen, a yellow molecule is shown over here for your understanding. Now this yellow molecule will coincide or will collide with two surfaces. The very first surface, as you can see over here, it will collide first with the bottom surface and then it will collide with the other molecule, right? So there are two collisions that are taking place. So free path means what? Free path means the path travel between two successive collision, that is known as free path. So as you can see here, the line that I have drawn, that is nothing but the mean free path, right? Now here mean free path means what? Simple. You have to take mean of the all free paths together. That will be known as mean free path. Now, what is the violation of the continuum concept? The violation of the continuum concept is that if the mean free path is having the magnitude equal to the magnitude of the volume of the vessel, then you can take that it is violating the continuum concept, right? Now, let us understand certain definitions. So, for understanding the definition, I have plotted PV diagram. So, I have taken pressure on the y-axis and taken volume on the x-axis. The very first definition is properties. So, what is the meaning of properties? So, in order to describe any physical condition of a substance, you will require certain characteristics. So, that characteristics are known as properties. For example, if you want to define the hotness or coldness of a substance, then you will require temperature. So that temperature is nothing but the property. Now, if the property has certain definite value, then it will be known as state, right? So as you can see on the PV diagram, I have plotted one state. So particular to this cross mark, you will have a particular pressure value and you will have a particular volume value, right? On respectively y and x axis. Now, if any operation is done in which one or more than one property is getting changed, then it will be known as change of state. So if you are moving from this cross mark to this cross mark, then you can appreciate that the pressure and volume both will get changed. So both properties are changing. So that moving from first cross mark to the second cross mark, that will be known as change of state. Now further, path. So succession of change of state will be known as path. Now if the path is completely defined, so that will be known as process. So for your understanding, I have shown over here constant pressure process by a horizontal line. So path is completely defined. So that will be known as a particular process. For example, constant pressure process, constant volume process, then reversible adiabatic process, isentropic process, like that. And if the two or more processes are occurring such that the initial state is identical with the final state, then it will be known as cycle. So here you can see from 1 to 2 and from 2 to back to 1. So the initial and final state both are one number. So then this is known as cycle. Okay. So today we are keeping up to this point. Thank you.